Very good evening to one and all gathered here. In today's class, we are going to see about the fundamentals of heat transfer in engineering thermodynamics. So let us directly go with the basic concepts of heat transfer. So what do you mean by the heat transfer mechanism? So here there are two examples. So let me take any one example for a simple, easy illustration. So heat transfer can be defined as a amount of energy which is exchanged between two bodies which are available at various temperature, say higher temperature to lower temperature region. So the amount of heat transfer takes place based on the temperature difference present within the system. So apart from work transfer, here there are certain sign conventions we have to reformulate in the basic concept of heat transfer. So many of you will have a confusion between work and heat transfer. Normally in work transfer, the work done by the system is referred as a positive work done. But here in heat transfer, the heat flows entering into the system is considered to be the positive heat transfer. And similarly, the heat which is moving out of the system is a negative heat transfer, whereas in work transfer, the work done on the system with respect to a surrounding is considered to be a negative work done. So these are the point of discriminations. Many people will have a lot of confusion. So both are having extreme difference. When we are solving the problem, we will come to know in the next meeting. All other interactions with respect to the given surroundings are termed to be a work transfer. So the process in which there is no flow of heat, but only the work transfer allowed to occur continuously by interacting between the system and surrounding. So therefore, such a type of process, a thermodynamic process, we call as a adiabatic process. So coming to the theme of presentation, heat transfer is said to be the path function. So in the previous, the 2-3 classes, we saw about a state function and path function. 2 classes before, we saw about the difference between state and the path function. So now once again, we will just reconsider what is the difference between the two terms. So state function, you take a pressure, temperature, volume. So these variables will change according to the specific time horizon based on the graph PV diagram. But the path function, so the change which occurs through two intermediate state. Say if you take in a graph PV diagram, so volume V1, V2. So these are the two intermediate states. So the heat flow which takes place between the two intermediate point, we call that as a path function. So through that path route, the change of the point variable takes place. So this can be given by the equation integral d dash into q is equal to q12. D dash is the inexact differential of heat transfer. Similarly for work done. Now the final equation for heat transfer, q is equal to integral t dx. So subject to the lower limit 1 and upper limit 2. So From this equation, it is clear that the heat transfer equation can be expressed by means of the change in temperature difference between the two different states. So with this lecture, I thank each and every one of you for your continuous support. So kindly share the useful information to your neighboring contact links. So thank you, Ananda.